Bear with me as I am using my computer and doing touchscreen with my finger versus doing this on the smartboard. So I'm sorry, it might not look the greatest. Anyway, we are going to be talking about statistics today in the numerical sense. And what I mean by that is we're going to be looking at specifically spread and talking about how you can compare and contrast your different graphs. So we've talked about, and this is all one variable data. We've talked about histograms, we talked about stem and leaf plots, box and whisker plots. Dot plots are basically the same thing as stem and leaf plots, but there are ways to compare them when talking about either the mean, median, or mode, or a standard deviation. So to start off with, when we're talking about spread, there's a couple different things that you need to know. There are basically three different types of graphs. Okay, so with these graphs, we have here what is called a normal or a bell curve. This one here, most of the data is towards the right, but we have outliers on the left, so this is what we call skew left. This one over here obviously is the opposite. This one is skew right. So what that means is our outliers are pulling the data to the left there, and then on the skew right, the outliers are pulling the data to the right side. With a normal curve, we don't have outliers. The majority of our data is in the middle. So with that being said, the mean and the median are close together in the center. I wish that would have just dropped that, but whatever. Okay, with skew left, a little bit different there. Skew left, the mean is lower than the median. Because of that, the outliers are pulling that mean towards the tail. So obviously with skew right, the mean is higher than the median. Again, the outliers are pulling it. So we have three different types of graphs. You'll be asked to identify, where's the mean, where's the median, all of that good information, as well as is there a skew? If there is a skew, what direction is it going? You could have the same thing with box and whisker plots. It just looks a little bit different. So like if you have the skew left situation, the box is going to represent that hump, and then the tails are basically your whiskers. So same kind of concept there. With that being said, I did mention there is another way to measure. There is another way to measure your spread, and that is with standard deviation and variance. Sorry, new to this, so just trying to figure out what I'm doing here. So let's see if I can delete all of this. Yes, clear page. Perfect. Okay, so we have a standard deviation. And again, this just measures spread. Okay. If you want to get technical, there is a formula in order to calculate this, but personally, I think it's a little bit easier to calculate the standard deviation using either a graphing calculator or Desmos, which I will show you that in a little bit. I want to talk about what this means and how it is affected with our normal curve. So again, our normal curve oh yeah, that looks like a pretty good bell curve. Pretty good today. Anyway, so our mean is generally in the middle. Okay, no questions about it. So when we are one standard deviation away, what that means is 68% of the data lies within one standard deviation away. So let's mark that down. And this only works with a bell curve. So one standard deviation, 68% of the data falls within the mean. So what that means is technically you have 34% above the mean and 34% below the mean, okay? Which that makes sense. If you have two standard deviations within the mean, that now is going to change. Two standard deviations within the mean is going to give you 95% of the data. Now notice we had a big jump there, and that's okay. It's just something to note. Then within three standard deviations, I don't want text, come on, pen. If you're within three standard deviations, this one is going to cover almost all, if not everything. Oh man, that changed that color. We'll get that adjusted. So three standard deviations away from the mean is 99.7% of the data. So with that being said, you're going to have to calculate some of this information individually. I want to edit that. Wonder why it won't let me edit that. Oh, there we go. Sorry. New app. Not always sure what I'm doing here. Like I said, if 34% of the data is here, then you'd have to calculate how much is here and then figure out those individuals within that. So looking at this, when we're talking about standard deviations and you're talking about the spread, that just kind of gives you an idea of what the graph actually looks like in terms of that standard deviation. And I say that because it's going to tell you, kind of similar to our 5-number summary when we figure out our boxes for our box and whisker plot, it's going to give you an idea of how concentrated those numbers are versus how unconcentrated those numbers are. Last but not least, I wanted to show you guys how to calculate this using Desmos. All right, so I'm in Desmos. I just typed in some numbers. Remember, you can get to that using the plus sign and then add a table and then enter your data. I just used some numbers to represent wind speed over a course of, looks like 6 days. If you click on this button, you get kind of like what it looks like on your phone. Then we have functions here. If you go to statistics, there's a lot of different things that you could find. You could find your mean, your median, your min, your max, your quartile, all of that good information. Notice there's one here that says STDEV. Obviously, this one's going to be our standard deviation. Once you click on that, it needs to know what we're finding the standard deviation of. Since this is the title of my list, I'm going to type in X1. It automatically knows to do the subscript, so you're good to go. So the standard deviation is 5.702. Okay, but what does that mean? So realistically, I need to find the mean then. If I don't have the mean, then it doesn't mean much to me. So the mean here is 9.783. So what that means is your 68% of your data is going to fall within, there's my mean, plus that standard deviation. Or, that's the upper half obviously, so it's going to go 15.48. Or my lower half of 9.783 minus 5.702. Okay, so if I'm looking at, I'm going to write these numbers down. If I'm looking at my bell curve, Okay, so if I'm looking at my bell curve, let's get a new one here. Okay, so this is my mean, and my mean there is at 9.783. This value here is at 15.485. This value here is at 4.081. I could then calculate, if I really wanted to, my how far is 2 standard deviations. So then I would add that 5 point whatever it was that I can't remember off the top of my head, add that onto there in order to get my 2 standard deviations, or do it minus that to get those values. So that's just kind of how you're calculating those values using Desmos. Very simple, very quick. Obviously, there's a lot of information within this. So there's our talk about spread and how to find different information based on that spread.